before you connect the actual Connect device to your PC, because otherwise the drivers will not already be in place. So you'll get the drivers, you'll get some documentation on sort of the programming API. You'll also see some samples in a zip file. You'll actually, let me open it and show you what you get. So you get some samples, both managed samples and unmanaged samples, which is both .NET samples and C++ samples, for doing things like audio and how to record audio and how to do beamforming on audio, how to use a skeletal tracker system, like a vision system, a camera system, and you get basically a full game. In fact, it's called the Shape game, that actually brings all of this together: the audio subsystem, the audio subsystem, and the vision subsystem into an actual playable game. And obviously, the Microsoft, the license agreement across all samples and across all code in CodePlex and all of that states that you can take this code and use it any which way you want in your own application. So feel free to reuse or modify this code, is what we said. The two most important things we care about are the actual libraries that you use to program Connect in your own application. If you're writing C++ programs, your libraries are going to be in these two files. The files called INC, the include files, and the lib files. So INC has all the header files that you can bring in, and the lib file is actually based on your platform, whether it's an AMD or x64 platform, has the lib files that you include in your C++ project. If you're doing .NET, the library lives in this folder called assemblies, and it's just this one DLL file called Microsoft.research.connect.dll, right? And this contains all of the the types in the Connect SDK that you can program against. And given that we're going to basically be, for this session at least, programming in C# and .NET, I will take the next 5 minutes to show you what is inside the Connect SDK. And to do that, I'm going to use a tool called the .NET Reflector. How many of you, actually let me ask you this, how many of you program .NET here? C#, VB, a few hands. Okay, so you probably are familiar with Reflector already. Actually, another question that I wanted to ask early on, how many of you have done any level of programming with the Connect? Like you've played with the SDK? There's about a few people already. Okay, that's fantastic. So that's about 6 to 8 people that I saw. Okay, that's great. So, with .NET Reflector, for those of us that don't do .NET, that haven't programmed .NET, basically what .NET Reflector does is think of it as a disassembler, right? It can take a DLL file, a library file, or a program file, and break it down and show you the individual classes and interfaces and even the actual properties and methods and even the source code for the properties and methods. So what I'm going to do is use .NET Reflector to open my Connect library file, so Microsoft.research.connect.dll. And so what this is going to do, okay. So what I did was basically, let me do it again because I don't think it was very clear because I have another window going. So let me delete everything. There's nothing in the Reflector file. Reflector window. I'm going to say go File, Open Assembly, choose the Microsoft Research Connect DLL file, and open it. And what this does is it loads the library inside the Reflector window. And when I expand it, it shows me all of the different namespaces and classes and methods and properties inside that library. I actually see that these are the 3 big namespaces, right? A namespace is just basically a big bundling of functionality of classes and interfaces in a logical sense. So for instance, in the Connect library, you can see that there are 3 namespaces. And if you cannot read in the back, all the way in the back, let me read it out for you. There's Microsoft.research.connect, there's Microsoft.research.connect.audio, and there's Microsoft.research.connect.NUI, NUI standing for Natural User Interfaces. The first one is just blank, it's just a placeholder namespace. But you'll see most of the functionality inside Microsoft or Research or Kinect or GUI, which basically controls all of the camera subsystems, your VGA camera, your depth camera, your player segmentation, the humanoid shape detection, obviously, and the skeletal tracking. All of that happens here. And all of the audio stuff in terms of beamforming and other features of the multi-array microphone like echo cancellation, noise suppression, all of that happens here. But just to give you a perspective, you can look at the amount of functionality in the audio segment versus the amount of functionality in sort of the camera subsystem, right? And the reason again for that is because most of the audio functionality is already built into Windows, right? So the Kinect SDK didn't have to reinvent all of that. So for most of the SDK, it's going to focus on the GUI subsystem, which is actually all the camera stuff. Now inside the GUI namespace, I'll make it slightly bigger so we can see more. You see that this, all of the classes, all of the interfaces, all of the other types are listed right there. And what you see is basically what there is, and that's it, right? And if you've done any sort of .NET programming before in any language, whatever type of application you build, you'll realize that this is a very compact namespace. There's only a few types that you worry about, and literally everything that you program on the Kinect has to do with these types. The most important class that you will always start with is this class called runtime. And let me expand this to show you what's inside runtime. So for those of you that are that can read C or C++ or C#, you'll actually see that this looks very similar to actual source code. In fact, when you write a class, you basically have this class declaration like public class, whatever class name, and then inside the class you have all of your methods and properties and variables and stuff like that. It looks very similar to that, right? And so that's what Reflector does. It basically takes a library and breaks it down. In fact, you can even expand all of the methods. You see all of these methods here. You can even get their implementation if you want by just clicking here. When I say expand methods, what it's going to do is it takes that class and breaks it down into the exact functionality as a developer would have written it. So this is basically all of the source code of this class, if you will. And this is a great way to learn C# or .NET programming, is by taking existing classes and see how it's actually written. But let me collapse it back so we can actually read all of this in one screen. And let's look at what runtime class offers us. Again, this is the one class that represents all of Kinect, right? All of the functionality you can access using the cameras inside the Kinect is all right up here. And let's, in the next 3 to 4 minutes, look at what's in here. If you look at, let's start with the properties first, because it gives you an idea of all the properties you can extract from the Kinect. You see that basically it exposes a few properties, the most obvious of which is the video stream, which is the raw stream from the RGB camera, and the depth stream, which is a raw feed from the depth camera. It also exposes some metadata type information like instance index and instance name, which basically, if you're chaining multiple Kinects, it'll allow you to identify one Kinect from the other Kinect and so on and so forth. It also has a status property which tells you if the Kinect is initializing, or if it's running, or if it's shutting down, and so on and so forth. Literally, that's it. The two obviously important properties are the depth stream and the video stream, which is basically going to return to you the raw data from the cameras. In terms of events, you'll see it actually exposes 3 events. An event is a mechanism in .NET, as in C++, to indicate that something is ready or something has happened and is ready for consumption. And so Kinect runtime uses these events called video frame ready and depth frame ready to indicate time's up. Okay. To to indicate that a frame is ready to be read from the video camera or the depth camera, right? So literally, this is the programming model, as simple as this. You basically, and we're going to come back and actually start coding right after we come back from lunch, but basically the structure that you will see us take is this. We will create an instance of this class called runtime, and then we will use methods like initialize to initialize our connect, and then we will wait for these events like video frame ready and depth frame ready to fire, because that means it's telling us that the camera has read a frame and it's ready for us to consume it. And then we will use these properties, the video stream and depth stream, to actually read that into our application and consume it any way we want. Right? In our app, we probably try to show it on the screen, but if you're building a game application, you can use the depth stream and or you can hook into the scalable frame ready event and get this joint information and do gesture tracking or whatever you want to do, right? But this literally, what you see in front of you is the API. And like I said, if you've done any level of programming before, you realize that this is an extremely simplified API, right? So it's really easy, it's really intuitive, as you'll see when we come back and start coding. So with that, I think from my perspective, I'm good on the content I wanted to cover before the break. But if there are any questions, I'm happy to take that now. What we're going to do after coming back is actually get into the Visual Studio editor and start writing code. But any conceptual questions before that, I'm happy to take now. Okay, so was there a question there? No. Okay. So with that, we're ready to go on a break, and I turn it back to you.
Okay. Thank you, Krishna. 我们掌声谢谢 Krishna。好，那我们接下来呢有1个小时的午餐的时间，要麻烦大家拿着您的午餐券，然后移驾到门外去领取您的餐盒。那因为我们今天到场的人数很多，要麻烦坐在右手边的来宾从右边的门出去拿餐盒，左边的来宾呢就从左后方出去拿餐盒。那麻烦大家。